Databricks Lakeflow Jobs is the orchestration layer inside Databricks. Think of it as the control center that coordinates your data workflow from start to finish. Instead of running notebooks, SQL scripts, Python code, dbt transformations, or pipelines manually, Lakeflow Jobs lets you organize them as repeatable production workflows. A job can be triggered manually, scheduled to run at a specific time, or started by an event. In a real data engineering project, this is useful for workflows like ingesting raw data, validating it, transforming it, and publishing clean tables for dashboards, analytics, or machine learning. The main idea is simple. Lakeflow Jobs helps data engineers run data workloads in a controlled, automated, and observable way. A Lakeflow job is built from a few important pieces. First, we have tasks. These are the actual steps that do the work, like running a notebook, executing SQL, or calling a pipeline. Second, we have compute. This is where the task runs. It can be serverless compute, jobs compute, or an existing compute resource. Third, we have triggers. A job can run manually on a schedule, from an event, or continuously. Then we have parameters, which make workflows reusable by passing values into tasks. Dependencies control the execution order, branching, and parallel paths. Finally, notifications and alerts help us know when something succeeds, fails, or slows down. So, a Lakeflow job combines workflow logic, execution rules, and observability. This slide shows what happens when a Lakeflow job runs. First, the job starts from a trigger. That trigger can be manual, scheduled, event-based, or continuous. Then Databricks creates a new run. A run is one execution of the job definition, usually with its own run ID and parameters. Next, Databricks prepares or attaches the compute needed to execute the workload. After that, the tasks run based on the workflow graph, dependencies, and conditions. While the job is running, Databricks captures logs, metrics, outputs, and task status. Finally, the run finishes with a status, such as succeeded, failed, canceled, skipped, or repaired. The key idea is this: the job is the blueprint, and the run is one execution of that blueprint. Lakeflow jobs can orchestrate many different types of work inside one workflow. A task can run a Databricks notebook, which is common for PySpark, SQL, or exploratory data processing. It can also run a Python script or a Python wheel when you want more modular and production-style code. SQL tasks are useful for warehouse queries, transformations, and analytics logic. Pipeline tasks can execute data pipelines, while dbt tasks can trigger transformation models. For more advanced workloads, you can run jar files, Spark submit jobs, or even call another Databricks job. You can also use if-else and for each tasks to create branching logic or repeat work over a collection. The powerful idea is that one job can mix different task types into a single orchestrated workflow. Dependencies are what turn a simple list of tasks into a smart workflow. In this example, the workflow starts by ingesting data and then validating it. After validation, the job asks an important question: is the data valid? If the answer is yes, the workflow can continue and run multiple transformations in parallel, such as transforming sales data and customer data at the same time. Once both transformations are complete, the job can publish the final gold tables. But if the data is not valid, the workflow can follow a different path: send an alert, clean up resources, and stop safely. Lakeflow Jobs also supports run conditions, like all succeeded, at least one failed, or all done. This helps data engineers build workflows that react intelligently to success, failure, and partial results. This slide explains when Lakeflow jobs run and how many runs can happen at the same time. A job can run manually when a data engineer clicks Run on Demand. It can also run on a schedule, which is common for batch pipelines that load data every hour, every night, or every morning. Event-driven triggers are useful when the workflow should start after something happens, like a new file arriving. Continuous mode is recommended for workloads that need to stay active, especially streaming scenarios. Concurrency controls how many runs can execute at the same time. For example, limiting a job to one concurrent run helps avoid overlapping executions. Queuing is also important because extra runs can wait instead of being skipped. This makes production workflows safer, more predictable, and easier to manage. Monitoring is one of the most important parts of production data engineering. Lakeflow Jobs gives visibility into run history, task status, logs, mogs, metrics, notifications, and failures. In the run history, we can quickly see which runs succeeded, failed, are still running, or were skipped. The task graph helps us understand exactly where the workflow failed. For example, if the transform task failed, downstream tasks may be skipped because they depend on that step. Logs and metrics help us investigate duration, errors, streaming backlog, and slow tasks. Notifications can alert the team when a job succeeds, fails, or becomes slower than expected. Repair runs are especially useful because they allow us to rerun failed or skipped work without restarting the whole workflow from the beginning. That saves time, compute cost, and operational effort. To build reliable Lakeflow jobs, data engineers should follow a few important best practices. Use clear job and task names so the workflow is easy to understand. Keep tasks small and modular because smaller tasks are easier to test, debug, and repair. Parameterize workflows when the same logic needs to run for different dates, tables, environments, or business units. Design tasks to be idempotent, meaning they can run again safely without creating duplicate or incorrect results. Set retries, timeouts, and alerts so temporary failures do not break the whole pipeline silently. Choose the right compute option based on workload size, cost, and performance needs. Monitor runs frequently and repair failures quickly. The final idea is simple. Lakeflow jobs turn separate tasks into a reliable, observable, and production-ready data workflow.